Hi guys, welcome to this video. In this video, we're going to talk about the type of indeterminate forms. Okay, indeterminate forms are forms that we obtain when we take a limit, either to the infinity or to zero. Okay, when x goes to zero or to the infinity. Okay, so I've started here to give a couple of a type starting by A, and this is the first one. This is kind of when you get to this form here, this first one here, it is L'Hopital's friendly. Okay, so it means that if you got here, of course what you're gonna do is to take the derivative of both the numerator and the denominator, as much as possible. Okay, so this is the first one. Is 0 over 0 and plus minus infinity over plus minus infinity. Those are indeterminate form. So this is an example: x to the 4 and divided by x. As you can see, if you plug 0 in x to the 4 here, you're gonna have 0, and you plug 0 in an x here in the denominator, you're gonna have 0. So you're gonna certainly have a 0 over 0, and that way, so you got to take derivative here. Okay, take derivative. First derivative, you gotta have like a full x to the power 3, yeah, divided by 1, and then the denominator will disappear. Therefore, you can apply the limits. You can take the limit, and then it's going to give you 0. And the second one is 0 times infinity. And I got an example here. This is the log limit of x times log of x. Okay, log of x when x tends to the infinity. Okay, the method here is quite simple. It's like you just have to turn it, you have to make it, to turn it into uh, one of these form here, either 0 over 0 or infinity over infinity. Okay, so you got to do what you got to do here is to turn it. Okay, you turn this form here, turn into a one of both. Okay, and then take the derivative, and then take the derivative. Okay, so let us just do what does that mean for this example here. Let us just do show an example, just show what it means. We have in here, okay, we have in here um, x times log of x. So an example, we will say, what I mean is that this we can write this like limits when x tends to 0, a little bit bigger, and turn this one here and say that it is log of x divided by x to the power of minus 1. So this is the same thing. Okay, I just you know brought x to the denominator. Okay, it is the same thing that I wrote here, and this actually means that it is log of x divided by 1 and divided by x. Okay, now let us apply the with the limit here. Sorry, limit x to 0. Okay, let us apply the limit on it now. If you put 0 here, you're gonna have the infinity. If you put 0 here, you're gonna have the infinity. We still have infinity over infinity, but we can continue to derive to take a derivative. Okay, and the derivative of the logarithm of the log, this be limits x tends to 0, and the derivative of log is 1 over x. Okay, and then the derivative of what here in the denominator is, when you take the quotient rule, that will be 1. Derivative of what is here is 0 minus times the numerator minus derivative of numerator is 1 times the numerator over x to the power of 2. Okay, and this gives you minus 1 over x to the power of 2, and we can put it here, it is 1 over minus 1 over x to the power of 2. Okay, so and this is actually, because there's a division here, we can turn it into a multiplication. So that's going to give us the limit when x tends to 0 of 1 over x times x to the power 2 over minus 1. So it's actually minus x. Okay, so that's what we get at the end. And then as you see, the limits at this step here will be equal to 0. Okay, so this here will be equal to, it is equal to 0. Okay, so now the other type will be, we got C. The other type will be when you get hold on, when you get 0 to the power 0, or 1 to the power of infinity, or infinity to the power of 0. Those are other type of indeterminate forms. So as an example, I can take the limit when x tends to 0 of x to the power of 2x, for example. Okay, so as you can see, if you plug 0 in here and 0 there, you're going to have 0 all to the power of 0. So it is an indefinite form. The method we can use here is like we just need to take, to put the log on it. Okay, let me just show you what I mean. You can do, okay, we don't get, okay, so it's going on here. You're gonna use the log. Okay, you have to turn it into a log. Okay, you gotta take the log here. You gotta take the log of the function, of that function, right? Or expression, of the expression. Okay, so if you take the log here, for example, this is what it's going to give us. We're going to have the limit when x tends to 0, x to the power of 2x, or let me just write it the log direct. Okay, so it's going to be the log of x to the power of 2x. All right, remember when you put the log, when you take the log here, this power here is going to go front out. All right, so that's going to be now the limit when x tends to 0 of, we got 2x log of x, and this is actually that of the form we had before, and it's actually the same thing that's what we had before, this one here. So what you can do here is only, do what we did here, of course, right? Okay, so the last one here, I call it D. Okay, the last one here would be D. And an example, this last form is actually this one here. It's infinity minus infinity. Okay, as an example, okay, as an example, I can have the limits when x goes to the infinity of x to the power of 3 minus 2x to the power 2 plus 3. Okay, as you can see, if you plug infinity, the infinity here, this goes to the infinity, this goes to the infinity, and plus 3, the whole thing, that would be infinity minus or plus infinity, something like that, but it's still this case here, right? So what we can do here is, so in this last example here, what we're going to do is that we'll take it here, we're going to remove the common factor with the greatest exponent, and it looks like this. Let me say the limit, for example, give it that the limit x tends to infinity, they would put x to the power of 3 as a common factor, then remain here 1 minus 2 over x and plus 3 over x to the power of 2 of 3, sorry, it is 3 here. Yes, of course, to the power of 3. Okay, and so now we can apply the limits. As you can see, this limit here goes to 0. This one goes to 0. And of course, this one here goes to the infinity. Okay, so it goes to the infinity. So as you can see, we have infinity times 1 minus 0 and minus 0. Okay, so the whole thing here, can go disappear. They still have infinity, and our result is actually the infinity, right? So we got it to the infinity, and here the limit is, you can say, plus minus infinity. It really depends on the sign of the coefficient of highest degree. Okay, okay guys, I think we're done with this exercise, with this indeterminate forms here. In my next video that I call it next, okay, I'll be taking a couple of examples about what we did here, all these different type, of indeterminate form. Okay, so thank you for watching, and until next time, bye bye.